Hello everyone. Tonight, we dive into what we know about reality and how it works. Please let me know where you're listening from and what time it is for you. I love seeing how far these videos go. Now, dim the lights and let's ease into tonight's journey together. Reality, a word we use effortlessly as if we've grasped its full weight. We wake up, step into the world, and operate under the assumption that the world is just there, solid, fixed, tangible. But what if that certainty is the greatest illusion of all? At first glance, reality feels self-evident. It's the desk beneath your fingertips, the sound of traffic outside, the ache of memory, the arrow of time. Yet, the more we investigate, through the lens of physics, consciousness, cosmology, and mathematics, the less grounded reality becomes. It starts to dissolve beneath our feet like a mirage. For centuries, we treated space and time as immutable backdrops to the stage of existence. Newton's universe was mechanical, predictable, like a grand celestial clock. But then came Einstein, tearing down the rigid scaffolding and replacing it with something much stranger. Space and time fused into a single fabric, warped by mass and motion. Suddenly, reality wasn't what it seemed. Clocks ticked slower near massive objects. Rulers shortened when in motion. Time, the supposedly linear progression from past to future, bent and twisted under the force of gravity. Even then, it was just the beginning. Quantum mechanics exploded our comfortable worldview. It revealed that at the most fundamental level, particles don't behave like tiny billiard balls. They behave like waves of probability, smears of possibility, existing in multiple states at once until measured. A particle isn't somewhere, it's everywhere until you look. This isn't a metaphor, it's physics. The infamous double-slit experiment demonstrates it elegantly. Fire electrons one at a time through a barrier with two slits, and they create an interference pattern, as if they're waves interfering with themselves. But if you observe which slit an electron goes through, just look. The interference vanishes, and the electron acts like a particle again. Reality changes depending on whether you're watching. It's as if the universe doesn't decide what's real until consciousness enters the scene. And that begs the question, what is the relationship between consciousness and reality? In classical physics, consciousness was irrelevant. The world existed independently of observers, but quantum mechanics shatters that division. It places the observer inside the experiment. Some interpretations, like the Copenhagen interpretation, suggest that the act of measurement collapses the wave function, transforming probability into actuality. Reality, in this view, is not entirely objective. It's participatory. Others push this further. The late physicist John Archibald Wheeler once proposed observer participancy, suggesting that observers play a fundamental role in shaping the universe, even retroactively. He famously coined the phrase "it from bit," implying that all of reality emerges from binary yes-no questions, bits of information, answered through acts of observation. If the universe is built not from matter, but from information, then reality may not be a thing at all. It may be a dynamic process of knowing, an unfolding tapestry of measurement, experience, and entanglement. But let's not get ahead of ourselves. We have to ask, what is a particle anyway? In the standard model of physics, particles are excitations in underlying quantum fields. The electron isn't a little ball. It's a ripple in the electron field. Photons are ripples in the electromagnetic field. Reality, then, is more like a vast ocean of invisible energy, with particles as tiny waves on its surface. Yet these waves are governed by mathematical abstractions so strange they defy common sense. They can interfere with themselves. They can be entangled, meaning that two particles, regardless of how far apart, can affect each other instantly. Einstein called this spooky action at a distance. We now call it quantum non-locality, and we've verified it experimentally countless times. If two particles are entangled and you measure one, the other instantly assumes a corresponding state, even if it's on the other side of the galaxy. No signal travels between them, no energy, no particle, no wave. The change is instantaneous, as if the two particles are not two, but one thing split across space. This challenges our very understanding of separateness. What does it mean for two things to be different if their states are entangled beyond distance or time? It gets stranger. Some physicists and philosophers argue that space itself is emergent, that it arises from entanglement. Think about that. Space, the very stage on which reality unfolds, might not be fundamental. Instead, it might be a convenient illusion generated by deeper relationships between information. You don't move through space, you move between patterns of entanglement. In this view, geometry is born not from objects, but from the abstract connections between quantum bits. The more entangled two regions are, the closer they are in space. The less entangled, the further apart. Distance becomes a derived concept. This is no longer science fiction. It's the basis for major research in quantum gravity and string theory. If space is emergent, what about time? Time is even more slippery. We experience time as a continuous flow, from the past through the present to the future. But physics sees time very differently. Einstein's equations treat time as just another dimension. The block universe interpretation of relativity suggests that all moments, past, present, future, exist simultaneously. Your birth, your death, and everything in between are laid out in a four-dimensional tapestry. In that view, the flow of time is an illusion. It's not that time moves, it's that your consciousness moves through time, like a needle playing a vinyl record. But quantum mechanics adds another layer of confusion. At the quantum level, time may not even be necessary. The most fundamental equations of physics, like the Wheeler-DeWitt equation used in quantum gravity, don't even contain time as a variable. It's missing entirely, as if the universe at its core is timeless, static. So where does the sensation of time come from? Some argue it's thermodynamic, an emergent property of entropy. In simple terms, the arrow of time exists because there's more disorder in the future than in the past. A broken cup doesn't reassemble itself because there are more ways to be broken than whole. But this says nothing about why time feels like it flows, or why we only remember the past and not the future. Time may be nothing more than a perceptual ordering device, a way our minds make sense of a fundamentally timeless universe. And speaking of perception, let's not ignore the role of the brain. Neuroscience shows that the brain constructs our experience of reality through a complex dance of prediction, filtering, and internal modeling. You don't perceive the world directly, you perceive your brain's best guess. Take color. There's no red in the world. There are electromagnetic waves of certain frequencies, and your brain interprets them as red. Sound? Just vibrating air molecules. Smell? Chemicals interacting with receptors. Every sense is a translation, filtered through biology, past experience, attention, and meaning. This means your reality isn't the reality, it's a rendering. Even time itself is filtered. The brain stitches together events across milliseconds to give the illusion of continuity. It edits out delays, fills in blanks, smooths over contradictions. The result is a seamless virtual world, a controlled hallucination, as some neuroscientists call it. So what happens when this hallucination breaks down? In certain states, like dreams, psychedelic experiences, or deep meditation, people report radically different perceptions of reality. They speak of timelessness, oneness, or the dissolution of the self. These aren't necessarily delusions. They may be windows into alternative modes of awareness. That's not to say we should throw out science, but it does suggest that consciousness is not a passive observer of reality. It's an active participant, a co-creator. And here lies a mystery deeper than any black hole or particle field. We don't know what consciousness is. Despite advances in neuroscience, we can't explain how subjective experience arises from matter. This is the hard problem of consciousness, coined by philosopher David Chalmers. We can map the brain, we can trace neural pathways, but how do firing neurons create the feeling of red or the sense of self? Why should matter wake up at all? Some scientists argue consciousness is an emergent property, like wetness from water molecules. Others suggest it's fundamental, like space or time. Still others, like proponents of panpsychism, claim that consciousness is woven into the very fabric of the universe, present in varying degrees in all things. Then there's integrated information theory, which tries to quantify consciousness as a kind of informational structure. The more integrated and differentiated a system is, the more conscious it is. Under this view, the brain is conscious because it's a highly integrated network. A simple thermostat is not, but there's no consensus. Consciousness remains the ghost in the machine, the one thing science observes constantly, yet cannot fully explain. So what do we have? A universe where matter is probability, where observation shapes outcomes, where time may not flow, where space may not exist, and where consciousness, the very thing asking the questions, remains the deepest mystery of all. Reality is not what it seems. It may not even be a thing at all. It may be a dance of perspectives, a hologram of probabilities, a story told by equations and dreams alike. And if that's true, then we haven't just underestimated reality. We've misunderstood the very stage we're standing on. If reality is not solid, not fixed, not even fully real in the way we once believed, then what is it? Is it energy, information, a projection? Could it perhaps be something even more radical, a simulation? The simulation hypothesis, once relegated to the fringes of science fiction, has gained serious attention in recent years. It proposes a simple but staggering idea that what we call the universe, stars, galaxies, atoms, ourselves, is actually a computational construct, a simulation, a vast and intricate program running on an unfathomable substrate we cannot see. This isn't just philosophical speculation. It arises from very real clues in the mathematical and physical structure of the universe. Start with digital physics, the idea that the universe, at its core, operates like a computer. Not necessarily a laptop or a smartphone, but a vast processor of information. The late physicist John Wheeler said, "It from bit," suggesting that every particle, every force, every interaction arises from binary yes or no questions. The universe isn't made of stuff, it's made of bits. That might sound abstract until you realize that we already simulate realities all the time. Video games, virtual reality, digital twins. The resolution improves year by year, and the characters inside these simulations follow consistent laws. Gravity, light, interaction. If one day a civilization reached enough computational power, what would stop them from creating a fully immersive simulated universe? One with conscious agents inside. This is the core of philosopher Nick Bostrom's argument. He proposed that if any advanced civilization in the future could run ancestor simulations, recreations of their evolutionary past with conscious beings inside, then statistically, it's far more likely we are in such a simulation than the one base reality that created it. Think about it. If a civilization creates millions of simulations, and each simulation contains billions of simulated minds, then conscious experience would be vastly more common in simulations than in the original world. The odds tilt dramatically. Of course, the simulation hypothesis is not just about statistics. There are strange physical clues that suggest a deeper digital architecture beneath reality. Take Planck units, the smallest measurable units of space and time. According to modern physics, there's a lower bound on how small distances and durations can get. You can't divide space infinitely. Eventually, you reach a fundamental pixelation of space-time. If that sounds like pixels on a screen, that's the idea. Reality may be granular, not continuous. And then there's the speed of light. 299,792,458 meters per second. Why does it exist at all? In a simulation, the speed of light might represent a maximum refresh rate, a speed limit imposed by the underlying system to maintain causal consistency. Just like a video game has a frame rate, the universe might have a computation rate. We also observe strange mathematical efficiencies in physical laws. The equations that govern reality are elegant, compressed, and symmetrical. It's as if they were optimized, written for simplicity, like good programming. Nature somehow prefers compact code. Another clue comes from quantum error correction. This is a principle from computer science that allows a system to protect information by distributing it redundantly. Surprisingly, physicists working in quantum gravity and black hole research discovered that the equations describing space-time closely resemble quantum error correction codes. It's as if the fabric of reality is engineered to preserve information from loss and corruption. But perhaps the most unsettling idea is this. If we are in a simulation, it may be impossible to prove it from the inside. Just as a character in a video game can't see the code, we may be forever locked inside our layer of reality, constrained by the rules of our rendering engine. And yet some researchers believe there may be ways to detect anomalies, bugs in the matrix, so to speak, unexplained cosmic rays, irregularities in the cosmic microwave background, or limits in quantum randomness could hint at artificial constraints. But no definitive evidence has emerged. Still, the idea persists because it explains so many otherwise inexplicable features of our world. The fine-tuning of constants, the mathematical perfection of laws, the strange limits on measurement and information. It offers a coherent, if deeply unsettling, framework. But even if the simulation hypothesis is wrong, it forces us to confront an essential truth. Our reality behaves like a system governed by code. Mathematics lies at the heart of everything. From the spiral of galaxies to the orbit of electrons, the laws of physics obey abstract equations. Why? Why does the universe speak the language of math so fluently? This is what Eugene Wigner called the unreasonable effectiveness of mathematics in the natural sciences. Numbers don't just describe the universe, they seem to structure it. And this raises a question. Did we invent math or discover it? If we invented it, why does it predict things so precisely? Things we couldn't have known. If we discovered it, where do these mathematical objects exist? Outside space and time? In some platonic realm? And if so, how does that realm interface with the physical world? Some physicists, like Max Tegmark, argue that the universe is a mathematical structure, not described by math, but identical to math. In his mathematical universe hypothesis, he claims that every consistent mathematical structure exists, and we inhabit one of them. This is a radical idea, but it solves several mysteries at once. It explains why the universe is so precisely lawful, why it has a consistent architecture, and why mathematics is so potent. It removes the distinction between the abstract and the real. To exist, in this view, is to be mathematically coherent. And it leads to yet another mind-bending consequence. There may be countless other mathematical universes, other realities with different constants, dimensions, even logic. Alternate realities not just as science fiction, but as inevitable outcomes of mathematical possibility. If that's true, then our universe is just one node in an infinite lattice of realities, each a self-contained realm of mathematical truth. We just happen to be in the one that supports life. And this brings us to another question. Why does our universe support life? This is the fine-tuning problem. The laws of physics contain constants, values like the strength of gravity, the charge of the electron, the expansion rate of the universe, that seem incredibly precise. If they were even slightly different, stars wouldn't form, atoms wouldn't hold together, life couldn't exist. Some take this as evidence for a creator, others for a multiverse, an infinite ensemble of universes, each with different settings, where ours is just one that happens to work. But within the context of simulation, there's another possibility. Maybe our universe was tuned because it was designed. Just like we tweak the rules in a video game to make it playable, an advanced intelligence might have calibrated our reality for complexity, beauty, or observation. That doesn't imply a god in the traditional sense. It could be a civilization, a system, a process. The point is, the physical constants may not be random, they may be parameters. And if that's the case, then reality is not just physical, it is intentional. That brings us full circle to consciousness, because if reality is designed, or if it is fundamentally informational, then consciousness may not be a byproduct. It may be the goal. Think of a simulation that doesn't just simulate landscapes or particles, but minds. Minds that reflect, observe, question. Minds that experience. That's what we are. If this is true, then perhaps the deepest question is not what is reality, but why experience it. And that opens up a new frontier, where science meets philosophy, where physics meets metaphysics. A frontier where the questions matter more than the answers, where reality itself is not a destination, but a journey. A puzzle we're meant to explore from the inside. Imagine peeling back reality like the skin of an onion, only to discover that the layers are just shadows projected from somewhere else. Not metaphorically, literally. That's the essence of one of the most extraordinary ideas in modern theoretical physics, the holographic principle. It proposes that everything we perceive as three-dimensional, every planet, every star, every atom, every emotion, may actually be encoded on a distant, two-dimensional boundary, like a cosmic hologram. This isn't speculative fantasy. It arises from serious efforts to reconcile general relativity and quantum mechanics, two pillars of physics that, despite their success, don't get along. One governs the large, planets, gravity, galaxies. The other rules the small, particles, uncertainty, superposition. Bridging them is one of science's greatest quests. The holographic principle came to light in the context of black holes. These cosmic singularities are places where gravity is so intense, not even light can escape. They collapse matter into an infinitely dense point, and surrounding that point is the event horizon, the boundary beyond which nothing returns. In the 1970s, physicist Jacob Bekenstein proposed something strange. The information content of a black hole, the amount of information you'd need to describe everything that fell into it, was proportional not to its volume, but to the area of its event horizon. Stephen Hawking's work on black hole radiation confirmed this, revealing that black holes aren't entirely black. They emit radiation and can eventually evaporate. But this led to a paradox. If black holes can evaporate, what happens to the information inside? Quantum mechanics says information cannot be destroyed. But if it's not destroyed, where does it go? To resolve this, physicists like Gerard 't Hooft and Leonard Susskind proposed the holographic principle. It states that all the information contained within a region of space can be represented as information on the boundary of that region, just like a hologram, a two-dimensional surface that produces a 3D image. This radical idea gained traction with the development of the ADS by CFT correspondence by Juan Maldacena in 1997. In this duality, a gravitational theory in a higher dimensional space, anti-de Sitter space, is exactly equivalent to a quantum field theory on its lower dimensional boundary. Gravity in 3D is described completely by a theory with no gravity in 2D. This isn't merely theoretical elegance. It suggests that space-time itself is not fundamental. It is emergent, built from a deeper informational layer, projected like a hologram. The world we see, the one we believe we inhabit, may be a 3D manifestation of encoded data at the edges of the universe, but the implications go deeper. If reality is holographic, then locality, the idea that things are separate in space, begins to break down. Everything that appears separate in the 3D projection could be deeply connected in the underlying 2D code. What appears as distance might be illusion. This could explain quantum entanglement. In a holographic universe, two particles separated by light years might not be separate at all in the deeper reality. They may be side by side on the boundary, their entanglement a natural consequence of their proximity in the hidden dimension. It also opens up a re-evaluation of time. If space is a projection, then so might be time. Events, sequences, cause and effect, all could emerge from correlations on the boundary. The arrow of time may not exist fundamentally, but only as a feature of the projection. This reshapes not only physics, but perception. Consider how we interpret vision. The light that enters your eyes has bounced off objects carrying information, but your brain constructs a 3D world from this data. It doesn't see objects directly, it decodes signals. In a sense, your mind already turns information into spatial experience. You live within your own private hologram. If our brains can do this with photons and neurons, then why couldn't the universe do it on a grander scale? Why couldn't physical reality itself be a vast rendering of information on a cosmic boundary? And what is information anyway? In physics, information is not just a vague term. It's measurable, physical, and fundamental. Claude Shannon's work on information theory laid the groundwork for the digital age. In his theory, information is a reduction in uncertainty, measured in bits. The more uncertain you are about a system, the more information it carries when you learn its state. In thermodynamics, information and entropy are linked. The more information you lose about a system, the more its entropy increases. Black holes, again, provide a perfect example. The entropy of a black hole is proportional to the amount of information hidden behind its event horizon. This relationship between information and physical law suggests that reality is not built from matter, but from distinctions, from patterns, from relationships, from informational architecture. That architecture might be digital. Some physicists argue that the universe is ultimately discrete, like the ones and zeros of a computer. Others propose it is analog, fluid, infinite. But either way, the role of information appears central. We begin to see reality not as things existing in space, but as a network of interactions, an evolving web of probabilities governed by information and correlation. And this leads to a startling realization. What you perceive as you is not separate from the universe. You are part of the hologram, not a being within space and time, but a pattern encoded in it, a conscious ripple in the cosmic field of information. In this view, boundaries blur. The distinction between object and subject, between mind and matter, between self and universe, becomes artificial. You are not a passive observer of reality. You are an expression of it, an emergent phenomenon woven from the same fabric as the stars and the vacuum between them. This isn't just poetic, it's logical. Every atom in your body was forged in a star. Every thought you have arises from neurons obeying quantum laws. Every word you speak ripples outward through vibrating air, carrying information into the world. You are not looking at reality from the outside, you are inside it, of it. You are the hologram reflecting on itself. This is where modern science meets ancient wisdom. Many spiritual traditions have long held that the world is an illusion, Maya, a veil hiding the true nature of existence. The holographic principle doesn't prove this, but it echoes the intuition. What we call real may be just one layer, one rendering, one dream among many. And dreams may be more significant than we think. During REM sleep, the brain creates entire worlds, visual, auditory, emotional. Within dreams, we don't question their reality. We act, feel, suffer, rejoice. Only upon waking do we realize they were fabrications of the mind. So how can we be sure this isn't just another dream? A more persistent one, perhaps, but a dream nonetheless. Philosophers from Descartes to Chalmers have asked this. If we cannot trust perception, then what is the grounding for certainty? In the end, perhaps we must abandon the search for absolutes. Perhaps the question isn't what is reality, but what isn't. What is being filtered, excluded, suppressed in the construction of this experience? Our eyes only see a narrow band of the electromagnetic spectrum. Our ears hear only a sliver of frequencies. Our brains edit and compress reality into a manageable model. Most of what is, we miss. The full reality may be infinitely more complex, more multidimensional, more vibrant than our senses can grasp. We see only the surface of the hologram, not the full code. But here's the beauty. The more we look, the more the edges blur. The more reality reveals itself not as a static stage, but as a living process. A flow of awareness, information, and emergence. A mystery too vast for certainty, too beautiful for simplicity. We do not live in the universe. We are the universe experiencing itself. What if the very thing asking the question, what is reality, is itself the answer? What if the mystery of existence isn't something out there, but something within, disguised as your own sense of self? Science has given us a rich vocabulary for describing the external world. Quarks, fields, forces, galaxies. But when it comes to consciousness, the words begin to fall apart. For all our technological and philosophical progress, we still do not understand what consciousness is, how it arises, or even if it has a definable boundary. It is the most familiar thing in the universe. We live inside it, and yet it is the most enigmatic. Let's be clear, we are not talking about intelligence, computation, or behavior. We are talking about awareness, the raw first-person experience of being, the taste of coffee, the sound of rain, the feeling of being you. That interior light, unmeasurable and persistent, that turns a world of matter into a world of meaning. This is what philosopher David Chalmers calls the hard problem of consciousness. We can scan the brain, we can identify neural correlates of experiences, but no amount of physical description explains why subjective experience exists at all. Why doesn't the brain just process information like a robot? Why does it feel like something to be alive? Materialist science, the dominant worldview, assumes that consciousness emerges from complexity, that if you wire enough neurons together, awareness will spontaneously arise. But this is more of a hope than a theory. No current model explains the leap from mechanism to subjectivity. So what are the alternatives? One is panpsychism, the idea that consciousness is a fundamental feature of the universe, like mass or charge. Under this view, everything possesses some degree of awareness, not thoughts or minds as we know them, but a basic proto-consciousness. A quark doesn't think, but it feels in some primordial sense. When matter organizes into complex systems like brains, this awareness becomes richer, deeper, more reflective. This isn't a mystical idea, it's a serious philosophical proposal gaining traction among scientists and thinkers who realize that trying to explain consciousness purely from the outside may be impossible. If subjectivity is irreducible, perhaps it must be present at every level of reality. Another proposal is integrated information theory, IIT, which tries to quantify consciousness. It suggests that any system with a high degree of integrated information possesses some level of awareness. The measure of this integration, called phi, predicts the presence and intensity of consciousness. The higher the F, the richer the consciousness. Under IIT, even non-biological systems, like advanced AIs or possibly entire galaxies, might have some internal experience. But theories alone don't answer the existential riddle of selfhood. What is the I that experiences? Neuroscience reveals that the sense of self is malleable. It can be disrupted by injury, altered by psychedelics, dissolved in meditation. Brain scans show that the default mode network, a set of brain regions active when we're thinking about ourselves, can be quieted, leading to a loss of ego boundaries. People report merging with their surroundings, becoming one with everything, or disappearing altogether. If the self can vanish, who was asking the question in the first place? This leads to a deeper possibility that identity itself is an illusion, not in the dismissive sense, but in the way a rainbow is an illusion, not unreal, but dependent on perspective. Our brains build the story of me from memory, emotion, and sensory input. But this story is constantly changing. The cells in your body regenerate, your thoughts evolve, even your preferences and values shift. The you from 5 years ago is not the same as today, and yet we cling to continuity. Why? Perhaps because consciousness seeks to anchor itself, to know itself, to narrate a center from which it observes the world. But if we peel back that narrative, we find something startling. There is no fixed self inside, only a process, a stream, a witnessing. The 18th century philosopher David Hume described the mind as a theatre, but found no self watching the show, only flickering impressions, colours, sounds, thoughts, passing like images on a screen. The Buddhist tradition echoes this, describing the self as a bundle of aggregates, sensation, perception, formation, none of which are permanent or personal. So where does that leave us? It leaves us with consciousness, not as a thing, but as a field, a presence, an opening through which the universe becomes aware of itself. And that opens the door to another mystery. Is consciousness local or non-local? We usually assume that awareness is confined to the brain, but reports of near-death experiences, shared consciousness, remote viewing, and other anomalous phenomena suggest something stranger. Could awareness extend beyond the skull? While these experiences remain controversial, they raise important questions. Can a brain-generated model of reality explain everything, or are we overlooking a deeper substrate? Some physicists, like Roger Penrose, have speculated that consciousness may arise from quantum processes within the brain, specifically within microtubules in neurons. His orchestrated objective reduction, OR, theory proposes that quantum coherence could give rise to unified awareness. While unproven, it offers a bridge between consciousness and the quantum world, a domain already known to defy classical assumptions. But whether quantum or not, consciousness defies reduction. It isn't something you can observe from the outside. It's only known from within. You are it. The observer cannot fully observe itself, which brings us back to reality. What if consciousness isn't inside reality? What if reality is inside consciousness? This idea is found across traditions. In idealism, the philosophical view that mind is fundamental, matter emerges from awareness, not the other way around. The physical world is a manifestation within a greater consciousness. This doesn't mean reality is imaginary or fake, but that it is experienced reality, a process unfolding in awareness. In this view, space and time are not containers, but constructs. The world appears to be out there, but arises in here, like a dream, vivid and immersive, but ultimately born of mind. Even the physicist Max Planck, the father of quantum theory, once said, "I regard consciousness as fundamental. I regard matter as derivative from consciousness." This is not mysticism. It's the consequence of realizing that we never access matter directly, only our experiences of it. So what then is reality? A projection, a simulation, a field of entangled information, a waking dream within cosmic mind. Perhaps it is all these things and more. Perhaps reality is not a fixed thing to be solved, but an evolving mirror, reflecting back to us the questions we ask, shaped by the lens of consciousness. Each insight opens a deeper layer, Each answer births more questions. It is not a puzzle with a final solution, but a symphony of unfolding. You are not outside of it, looking in. You are it, looking at itself. When you look at the world, you see 3 dimensions: length, width, height. You move through a 4th, time. These seem obvious, intuitive, fixed. But modern physics tells us that there may be far more dimensions than we can detect, woven into the fabric of reality, hidden from sight yet influencing everything. To begin, let's look at string theory, a candidate for a unified theory of everything. It proposes that all particles are not point-like dots, but tiny vibrating strings. These strings vibrate at different frequencies, and those frequencies determine the properties of particles: mass, charge, spin. A photon is one string vibration, an electron another. But for the mathematics of string theory to work, it requires more than 4 dimensions: 10, 11, or even 26, depending on the version. These extra dimensions aren't imaginary. They are real, but compactified, curled up at scales so small they're invisible to our senses and instruments, like threads wrapped tight in the weave of space-time. Imagine an ant walking on a garden hose. From far away, the hose appears one-dimensional. It's just a line. But up close, the ant can move around its circumference. That's what these extra dimensions may be like. They exist, but at a scale too small for us to explore, at least for now. Why would the universe hide its dimensions? Maybe it doesn't. Maybe we are limited. Our senses evolved not to reveal reality, but to survive. We see only a narrow band of light between infrared and ultraviolet. We hear a tiny range of vibrations. We feel pressure, but not atoms. We interpret time as linear because that's what helped us avoid danger and find food. Perception isn't truth, it's strategy. Cognitive scientist Donald Hoffman argues that evolution shaped us not to perceive objective reality, but to create user interfaces. Just like a desktop hides the complex circuitry of a computer behind icons, our minds simplify reality into manageable metaphors. Trees, people, colors, clocks. These aren't the real structures. They're useful fictions. This suggests something radical. We may be blind to the most fundamental features of reality, simply because they're not needed for survival. Truth and fitness are not the same. So what are we missing? If extra dimensions exist, they might influence gravity, dark matter, or even consciousness. They may be vast, rich landscapes, folded just beyond our reach. In some models, gravity leaks into other dimensions, which could explain why it's so much weaker than the other forces. We don't feel the pull of extra dimensions, but perhaps we feel their consequences. And if reality includes higher dimensions, then our perception of separation may be an illusion. Think of how a 2-dimensional creature would perceive a 3-dimensional object. A sphere passing through its world would appear as a growing and shrinking circle, completely mysterious. That's how higher dimensional realities might interact with us. They pass through our 3D experience, appearing as inexplicable phenomena: quantum entanglement, dark energy, or even strange synchronicities we can't categorize. These may not be miracles or glitches, they may be the signatures of higher dimensional geometry. This expands the landscape of what reality could be. There could be beings, structures, or systems existing in these higher dimensions, entirely invisible to us. Not because they're far away, but because they're orthogonal to our perception. Like trying to hear a color or see a scent, we simply don't have the sensory apparatus to detect them. But there are clues. Mathematical symmetry is one. Nature is full of it. Rotational symmetry, mirror symmetry, gauge symmetry. These are the rules of how fields and particles behave, and many of them point to structures that only make sense in higher dimensional space. Another clue is the mysterious nature of time. We experience time as one-directional, always moving forward. But why? Nothing in the laws of physics mandates that time must flow. Equations work the same forward or backward. The arrow of time appears only when we introduce entropy, a measure of disorder. Systems naturally move from order to chaos. But entropy is statistical, not fundamental. So time's flow may be a byproduct of perception, not a law of nature. Some physicists believe that in higher dimensions, time might not exist at all, or may exist as multiple axes, like space. That would mean our linear experience of time is like being trapped on a rail, while other dimensions offer movement in entirely different directions we cannot see or imagine. If this is true, then past, present, and future are not separate. They coexist in a higher structure, accessible only from outside our timeline. What we call fate or destiny may simply be geometry. But how do we study what we cannot perceive? Mathematics becomes our torch in the dark. It allows us to infer what we cannot see. We use models, symmetries, and predictions to map territories far beyond our senses. It's through math that we discovered atoms, predicted black holes, and glimpsed the cosmic web that connects galaxies. And yet, even math may be limited. Our minds evolved in a particular environment with particular logic. Higher realities may operate on principles we cannot yet articulate, logics that transcend our models. So what tools do we have? Imagination, pattern recognition, interdisciplinary insight. These are not luxuries, they're necessities. To understand a multidimensional reality, we must think in multidimensional ways. And perhaps this is where art, philosophy, and mysticism re-enter the picture. Not as science, but as complementary ways of approaching the unapproachable. Metaphor, myth, and poetry often describe realities we cannot yet model. In dreams, people describe places that are beyond space. In meditation, they report timeless states of being. In altered states of consciousness, they encounter geometric patterns, extra-dimensional beings, and non-verbal understandings that feel more real than waking life. Are these merely hallucinations or glimpses into the structure behind the simulation? No definitive answer exists, but they point to a consistent theme. That reality is layered, that the familiar world is but one interface among many, that behind the curtain of perception lies something vast, intelligent, and alive in ways we've only begun to suspect. We may be like cave dwellers tracing shadows on the wall, unaware of the fire and figures behind us. And yet, something in us knows. We feel it in déjà vu, in the pull of curiosity, in the strange sense that life is deeper than appearances. Reality does not end at the edges of vision, it begins there. Time is often treated as a river, steady, unyielding, and always flowing in one direction. It carries us from birth to death, moment by moment, hour by hour, into the future we cannot see and away from the past we cannot change. But is that how time really works? Or is our sense of its flow just another illusion? One more simplification projected by the mind to make sense of something far more exotic. Einstein's theory of relativity already shattered the illusion of universal time. There is no single ticking cosmic clock. Time passes differently depending on how fast you move and how close you are to a massive object. A clock on a mountaintop ticks faster than one at sea level. Astronauts age more slowly than those on Earth. Time, once thought to be absolute, is revealed to be flexible, relative, and inseparable from space. This bending of time leads to the concept of time dilation, where two observers moving at different speeds, or sitting in different gravitational wells, experience different durations for the same event. But relativity goes even deeper. In the block universe model, time doesn't flow at all. Past, present, and future all coexist. Reality is a four-dimensional structure, where time is simply another axis, like length or height. What we call now is just a slice of the larger whole, a cross-section of a much greater reality. But if time is a dimension, not a progression, then what causes events to unfold? Enter causality, the principle that causes lead to effects. Strike a match and it burns. Push a cup and it falls. But even causality begins to wobble under quantum and relativistic scrutiny. In certain interpretations of quantum mechanics, like the transactional interpretation, causality is not one way. Events may be linked both forward and backward in time, like ripples converging from future and past to meet in the present. This brings us to closed time-like curves, solutions to Einstein's equations that allow for paths through space-time that loop back on themselves. In theory, these loops could allow for time travel, where an object returns to its own past. Wormholes, rotating black holes, or certain warped geometries could create such loops, at least on paper. But if time loops are possible, what happens to causality? Could you go back and change the past? Kill your own grandfather? Meet yourself? Paradoxes emerge, the grandfather paradox, the bootstrap paradox, challenging our notions of logic and consistency. Yet physicists have explored ways to resolve these paradoxes without violating physics. The Novikov self-consistency principle, for example, suggests that any actions taken by a time traveler were always part of history. You can go back, but you can't change what's already been written. Everything fits together in a self-consistent loop. This would mean that free will is constrained by geometry. The universe allows time loops, but only those that preserve consistency. No contradictions, just inevitabilities. In such a reality, cause and effect are no longer linear. They become circular, recursive. The effect might become the cause. The future might influence the past. Even in the quantum realm, strange temporal loops arise. Experiments with quantum entanglement and delayed choice suggest that decisions made in the present can affect the outcomes of measurements in the past. In these experiments, particles seem to know what future measurements will be taken and adjust their behavior accordingly. It's as if the boundary between past and future is porous, more like a feedback loop than a timeline. This challenges the very root of how we think about history and experience. If the future can affect the past, then what is memory? What is prophecy? What is decision-making? Perhaps time isn't a road, but a spiral, or a lattice, or a multi-dimensional manifold where timelines bifurcate, converge, and echo through higher-order patterns. And that takes us to the concept of the multiverse. If every possible quantum outcome branches into a new reality, as suggested by the many-worlds interpretation, then time doesn't just move forward, it expands. Every choice, every possibility, splits the universe into countless alternate histories. You don't live in a single timeline. You exist across a tree of timelines, each diverging with every breath. In such a universe, reality is not singular. It is plural. Time becomes a web of infinite potentialities, and your experience is just one thread among many. But what determines which thread you follow? This is where consciousness reappears, because you are not just a passive passenger on a timeline. You are an observer, a participant, a chooser. In quantum mechanics, observation determines outcome. In relativity, motion alters time. In consciousness, perspective defines reality. So perhaps you don't move through time. You select time. Your consciousness locks into one frame among the possibilities, collapsing the wave function of reality into the experience of now. And what is now, really? It's never static. The present is a paradox. The moment you try to capture it, it's already gone. The now we experience is a reconstruction, light arriving from the past, neurons processing signals, memories interpreting data. We live milliseconds in the past, thinking we're present. We chase the illusion of now, like a shadow we can never touch. Some traditions speak of the eternal now, a timeless presence beneath the ticking clock. In deep meditative states, time seems to dissolve. Hours become minutes, or minutes become infinite. Athletes in flow lose track of time. In trauma, seconds stretch into eternities. Time is elastic, subjective, and often utterly disconnected from clocks. So where does that leave our understanding? It leaves us with a humbling realization. Time, as we know it, may be a cognitive artifact, a strategy for making sense of a higher dimensional reality we cannot directly perceive. Our sense of sequence, cause, and duration may be tools, not truths. Reality, then, may not unfold in time. It may contain time, or be beyond it. And if we could step outside of time, what would we see? Perhaps all of history laid out like a sculpture. Perhaps all possibilities branching like a fractal. Perhaps a unity beyond change, where every moment is eternal, and every path already walked. Or perhaps we would see ourselves, not just as individuals moving through a story, but as the story itself. A loop within loops, a pattern etched into the fabric of the infinite. We are not simply passengers on the river of time. We are the river, the current, and the banks that hold it. When we strip reality down to its most fundamental layers, what remains? Not atoms, not energy, not space or time. What persists, what underlies it all, is structure. Patterns, ratios, logic. In a word, mathematics. It's easy to think of math as a human invention, a tool we created to measure, calculate, and organize. But the deeper we peer into the cosmos, the more it seems that mathematics isn't just descriptive, it's prescriptive. It doesn't just explain reality, it builds it. Look at the laws of physics. From Newton's equations of motion to Einstein's field equations, from the Schrödinger equation of quantum mechanics to Maxwell's equations of electromagnetism, all of reality seems to obey concise mathematical rules. Elegant formulas with symmetries, constants, and principles that hold true across the universe. It's as if the universe is not a chaotic accident, but a well-ordered program. This uncanny efficiency of mathematics in describing the universe has baffled some of the greatest minds. Physicist Eugene Wigner called it the unreasonable effectiveness of mathematics. Why should the universe conform to human logic? Why should abstract symbols written on a chalkboard mirror the behavior of galaxies? Unless the universe is mathematical at its core. That's the hypothesis of Max Tegmark, who argues that the universe is not just described by math, it is math. Every structure that can be defined mathematically exists physically. Under this view, reality is a vast space of mathematical possibilities, and we happen to inhabit one that allows consciousness to emerge. If that sounds abstract, consider this. Everything we observe behaves as if it's part of an ongoing computation. From the motion of celestial bodies to the behavior of subatomic particles, the universe acts like a vast algorithm, crunching through laws and outcomes. In this model, physical things aren't primary. Information is. Electrons, photons, even space-time itself may emerge from bits, units of information. John Archibald Wheeler captured this idea with the phrase, "it from bit." Reality doesn't emerge from stuff. It emerges from yes, no, one-al, binary distinctions, the foundation of all computation. Information isn't just part of the universe. It is the universe. Black holes provide stunning support for this. When an object falls into a black hole, what happens to the information it contained? For decades, scientists feared it was lost forever, violating a core principle of quantum mechanics. But recent breakthroughs suggest otherwise. The information isn't lost. It's encoded on the black hole's event horizon. This led to the holographic principle we explored earlier. All the information within a volume of space may be stored on its boundary. Reality, in essence, behaves like a computer processing code on the surface, projecting it inward into a 3D experience. Even time itself may be an emergent phenomenon, an algorithmic update across quantum states perceived as continuity. If you zoom in close enough to the Planck scale, the smallest measurable unit of space and time, you begin to see limits. Space becomes granular, time becomes discrete. Just like a computer program doesn't run continuously, but in ticks of a clock, the universe may operate on a quantum clock. One step, then another, then another. Each moment a computational refresh. Each moment a rendering of possibilities collapsed into a single outcome. And if this is true, then perhaps we live inside a kind of cosmic operating system. This doesn't mean we're in a simulation created by aliens or future humans. It means that existence itself may be computational. At every level, reality might obey logic gates, follow protocols, and preserve information. It behaves exactly as we would expect a self-generating code to behave. But here's the twist. The universe isn't digital or analog. It may be both, or something more. Quantum systems can exist in superpositions, not just ones and zeros, but infinite combinations of possibilities. A quantum computer, for instance, processes information not in bits, but in qubits, units that can be both 1 and 0 at the same time. This quantum logic underlies all matter. The table you're sitting at, a probability cloud of particles vibrating according to wave functions. Solidness is an illusion. What you feel is the electromagnetic repulsion between atoms. Underneath, it's all uncertainty, collapsed into form by observation. So how do these patterns give rise to reality? Through symmetry. Symmetry governs the laws of physics. It determines conservation of energy, momentum, and charge. It explains why particles behave identically across vast distances. It's symmetry that gives rise to predictability, to stability, to identity. When symmetry breaks, when a perfect pattern fractures slightly, we get diversity. Mass, electromagnetism, the difference between particles. It's from these tiny asymmetries that complexity arises. Galaxies, stars, life, all owe their existence to the breaking of a deeper, more elegant order. Nature is a dance between symmetry and asymmetry, order and chaos, pattern and randomness. It's the balance between these forces that creates beauty. Look at the Fibonacci sequence in flowers, hurricanes, and galaxies. See the golden ratio in seashells and sunflowers. Observe fractals in clouds and coastlines. These patterns are not accidents. They're the fingerprints of the underlying code. And the code is interactive, it evolves. Mathematics isn't static, it grows. With each new discovery, we unlock deeper levels of reality. Prime numbers, irrational numbers, imaginary numbers. They all found their place in the expanding universe of math, just as dark matter and quantum fields found their place in physics. We didn't invent these numbers, we discovered them. Like explorers finding new continents, we chart regions of mathematical space that were always there, waiting to be seen. This suggests that the universe is not made of things but relations. Between numbers, between particles, between observers. Reality is not substance, it is structure. And where there is structure, there is meaning. This is where mathematics becomes more than logic. It becomes language. Not just the language of numbers, but of being. The silent song of the cosmos, sung through ratios and orbits, waveforms and frequencies. We are part of that song. Our minds too follow mathematical principles, neural firings, pattern recognition, feedback loops. Our thoughts are shaped by logic, our dreams by symmetry. We think in metaphors, but even our metaphors follow form. So when we ask what is reality, we might really be asking, what is the code? What is the equation that holds it all together? What algorithm gives rise to consciousness, to matter, to love? Perhaps there is no single answer. Perhaps reality is a fractal, infinitely deep, infinitely recursive. A Mandelbrot set of truths within truths. But one thing seems clear. Mathematics isn't just a tool. It's the canvas on which reality is painted. And we are part of that painting, drawn in curves, spirals, and symmetries, seeking to understand the picture from inside the brushstroke. The more we discover about the mathematical structure of the universe, the more it begins to resemble something designed, coded, or rendered. The laws of physics are so precise, the constants so finely tuned, the structure so ordered, that an unsettling question inevitably arises. Is this real, or is it a simulation? What began as a science fiction trope has become a serious philosophical and scientific discussion. The simulation hypothesis proposes that what we perceive as physical reality may, in fact, be an artificial construct, generated by a computational substrate that exists outside of our perceived universe. The idea gained traction through philosopher Nick Bostrom's now famous argument. He proposed that one of the following must be true. All civilizations at our level of technological development go extinct before becoming capable of simulating universes. Civilizations that reach the necessary level of technology choose not to run such simulations. We are almost certainly living in a simulation. It's not an assertion, it's a probabilistic argument. If future civilizations can run ancestor simulations, detailed recreations of reality populated by conscious beings, then the number of simulated minds would vastly outnumber biological ones. Statistically, it would be more likely that you are one of the simulated ones. But the idea rests on a bold assumption that consciousness can be simulated. If minds are the result of computational processes, if thought is just information flowing through neurons, then, in principle, the same patterns could be recreated in silicon. A digital brain, a synthetic reality, a universe rendered not in atoms, but in code. Already, we simulate weather systems, galaxies, and ecosystems. Virtual worlds grow increasingly realistic. AI learns, adapts, and converses. Virtual reality becomes more immersive. It's not hard to imagine that, given enough processing power, a virtual world could be indistinguishable from a physical one to the minds inside it. And here's where it becomes eerie. There are features of our universe that resemble those of simulations. Take the Planck length, the smallest meaningful unit of space. Below this scale, space loses its smoothness and becomes pixelated. It's as if the universe has a built-in resolution limit, or the maximum speed of light, a cosmic speed cap. In computer graphics, limiting speed prevents glitches and ensures consistency. Could the speed of light serve a similar purpose? Then there's quantum uncertainty. Particles don't exist in definite states until observed, suggesting that information is rendered only when required, like a video game optimizing graphics by only loading what the player sees. These features are speculative, but intriguing. They point toward a reality that behaves more like a responsive simulation than a rigid machine. And if it is a simulation, then who or what is running it? That question opens doors to unsettling and enlightening possibilities. The programmers could be post-human beings running simulations for research, entertainment, or exploration. They could be alien civilizations studying the evolution of intelligent life. Or they could be aspects of ourselves, higher dimensional consciousnesses experiencing different facets of existence through immersion. Some argue that the simulators might not be beings at all, but abstract forces. Perhaps the simulation isn't built by intent, but by law, an emergent phenomenon of consciousness exploring all possible configurations. And if we are inside a simulation, what does that mean for meaning, morality, and identity? It doesn't necessarily diminish them. Just as characters in a novel experience real joy and tragedy within their world, conscious beings in a simulation still feel, think, and choose. Experience is real even if the substrate is virtual. In fact, recognizing the artificial nature of reality might enhance its significance. It implies purpose, design, intelligibility. We are not accidents in chaos, but parts of a system that follows deep rules. We are meant to be here, or at least we exist within a set of constraints that allow us to reflect on our own existence. Interestingly, ancient traditions echo this idea in symbolic language. Hinduism speaks of Lila, the divine play of consciousness creating the universe. Gnostic texts describe the world as an illusion built by lesser gods. Plato's allegory of the cave imagines humans watching shadows on a wall, unaware of the true reality outside. These are not literal simulations, but they capture the same intuition, that the world we perceive may not be the ultimate reality, that there is something behind the curtain. But what would it mean to break the simulation? If we live in a simulation, then perhaps certain glitches, anomalies, or paradoxes are hints. Déjà vu, synchronicities, improbable coincidences, could they be signs of recalibration or memory errors in the code? Quantum randomness might be the universe's way of inserting entropy to avoid predictability, keeping the experience dynamic. In digital environments, randomness is often simulated. It's pseudo-random, appearing chaotic but governed by deeper rules. Might quantum indeterminacy work the same way? A tool to create free will within a predetermined framework? Then there's the question of escape. Can a simulated being become aware of its simulated nature? In theory, yes, if the simulation allows for it. Awareness could be an emergent glitch, a spark of self-reflection that turns the avatar into a seeker. And if enough information is gathered, perhaps the simulated mind could detect the limits of its environment, identify the edges of the code. But escape might not be the point. If the simulation hypothesis is true, the purpose may not be to flee, but to explore, to understand the rules, to push the boundaries, to evolve within the simulation until new levels of awareness are unlocked. And this mirrors what mystics, sages, and visionaries have said for centuries. The path is inward, not to reject reality, but to question it deeply, to realize that what we call the real world is just one layer, one interface, one frequency among many. Even if this isn't a simulation in the technological sense, it might be one in the metaphysical sense, a reality rendered by a deeper mind, a dream from which we awaken again and again into greater clarity. In that sense, the simulation hypothesis doesn't explain reality away, it deepens the mystery. It invites us to ask, if this is not base reality, then what is? If there is a source, a substrate, a truth beyond the veil, how do we access it? Perhaps the answer isn't out there. Perhaps it's encoded in us, in our intuition, our curiosity, our capacity to question the very framework we inhabit. That questioning itself may be the key. Because whether we're living in a base universe, a dream, a simulation, or a projection, the fact remains, we are here. We are conscious. We are capable of asking, wondering, and seeking truth. And that is reality enough to begin with. At the heart of quantum mechanics lies a puzzle so deep and strange that it has haunted scientists and philosophers for over a century. Observation changes the observed. The act of measuring a system appears to collapse it into a definite state. Before observation, particles exist in superpositions, many possible states at once. After observation, they choose one. This is not a metaphor, it's a verified phenomenon. In the famous double-slit experiment, particles fired at a barrier with two slits create an interference pattern, suggesting they behave like waves, passing through both slits at once, but when you measure which slit the particle goes through, the interference disappears. The particle behaves like a solid object, only one path taken. Just the act of observing changes the outcome. Why? That's the mystery. Some interpretations suggest it's not the observer per se, but the interaction with the measuring device. But this only shifts the problem. Why does the universe behave differently when we attempt to extract knowledge from it? Other interpretations go further, suggesting consciousness itself may be fundamental to the process. That awareness is not just a side effect of physics, but a participant in it. The Copenhagen interpretation embraces this ambiguity. Quantum systems remain in superposition until measured. But what does measured really mean? Does reality require a mind to crystallize its possibilities? John von Neumann extended this idea by suggesting that the entire measurement chain, from particle to detector to human, remains entangled until a conscious observer looks. At that point, reality collapses into a single state. This idea, though controversial, returns us to a deep philosophical question. Is reality objective or participatory? Enter the participatory anthropic principle, proposed by physicist John Archibald Wheeler. He argued that observers are not separate from the universe. They're part of the mechanism by which it comes into being. The universe, in some sense, requires observation to manifest. He summarized this with a provocative phrase: "No phenomenon is a real phenomenon until it is an observed phenomenon." In Wheeler's famous thought experiment, It from Bit, he suggests that physical reality arises from binary yes, no questions. That information, not matter, is primary. And that observation, asking questions of the universe, is how the bits become its. Consciousness, then, is not an afterthought. It is central to the unfolding of reality. This raises profound implications. If observation collapses wave functions and we are observers, then we are not passive inhabitants of a pre-built world. We are co-creators, participants, agents in the rendering of the cosmos. This is echoed in quantum Bayesianism, or cubism, which treats quantum probabilities as personal beliefs about outcomes. In this interpretation, quantum mechanics is not a map of objective reality. It's a guide to how an individual observer updates their expectations. Reality is not what is out there, but what unfolds in the interaction between observer and system. And this mirrors what many spiritual traditions have said for millennia. The world you see is not separate from you. Perception is creation. Experience is entangled with the experiencer. But how far does this go? If consciousness plays a role in shaping quantum events, does it also shape larger systems? Can collective observation affect reality on macroscopic scales? In the Global Consciousness Project, researchers placed random number generators around the world, looking for correlations between collective human attention and statistical deviations. During events of global focus, like 9/11 or major celebrations, patterns emerged that were not expected by chance. While not definitive, such findings suggest a potential link between consciousness and informational structure, a subtle interaction, but one that challenges the idea of a completely mind-independent reality. Even at the level of biology, the observer effect manifests. Studies in neuroscience show that attention shapes perception. What you look for, you see more clearly. The brain filters the world based on belief, expectation, and focus. Reality is edited before it reaches awareness. So what is truly out there? Some scientists suggest the answer may be nothing until attention gives it form. In computer graphics, rendering happens on demand. The forest behind your game avatar isn't rendered until you turn toward it. This saves processing power. Could the universe function similarly? Is what we call reality only fully rendered when conscious awareness engages with it? That would explain the quantum weirdness. That would explain why unobserved systems exist as probabilities. That would explain why measurement, an act of querying the universe, causes collapse. It also elevates the role of the individual. If each observer participates in reality's unfolding, then each life is not merely passing through the world, it is sculpting it. The choices you make, the questions you ask, the attention you direct, all ripple into the fabric of being. This leads to a universe that is not deterministic, but creative. Not fixed, but fluid. Not inert, but responsive. And if that's the case, then meaning is not something we discover. It's something we generate. We do not find ourselves in a pre-written play. We co-author the script through our interactions, perspectives, and intentions. Perhaps this is why symbolic systems, myths, and rituals have always held power. They encode meaning into experience, guiding the observer through a symbolic interaction with the universe. In ancient times, this was called magic. Today, we might call it psychology, semiotics, or even quantum intention. But the root is the same. Attention matters. Reality notices when you notice it. So where do we go from here? We return, full circle, to the mirror. Reality reflects back what is projected into it. The questions we ask shape the answers we find. The beliefs we hold shape the data we notice. The stories we tell shape the world we inhabit. This is not solipsism. The universe is not just your imagination, but neither is it completely separate from you. You are not outside looking in. You are inside and looking out. The observer and the observed. The I and the image. The question and the unfolding answer. In this view, the universe is not just governed by physical laws, but by participation. It is not static, it is responsive, and every act of observation, every moment of attention, is a note in the great composition of being. You are not an outsider to the cosmos. You are its instrument, its echo, its awakening. After traversing the landscapes of physics, consciousness, mathematics, and perception, one truth becomes clear. Reality is far more complex, subtle, and wondrous than any single explanation can contain. It resists the final word, the definitive answer. Instead, it invites us into an endless journey of discovery, a dance with mystery itself. Science has given us incredible insights, revealing that space and time are flexible. Matter is energy, particles behave like waves, and consciousness might be fundamental. It has shown that dimensions may be hidden, that reality may be a vast computational tapestry, that our minds may shape what we perceive. Yet each answer births new questions. Are we living in a simulation? Does consciousness create reality? Is time an illusion? Are we co-creators or mere passengers? These questions challenge not only our intellect, but our very sense of identity and place in the cosmos. Perhaps this is the most profound lesson, that reality is not a puzzle to be solved, but a mystery to be lived. A mystery that invites humility, wonder, and awe. To embrace the unknown is to open the door to new possibilities. It's to recognize that certainty is a comfort, but not a destination. That knowledge is a map, but the terrain is ever shifting. Our experience of reality is a tapestry woven from sensation, perception, belief, and interaction. It is a story told in countless languages: science, art, philosophy, spirituality. Each offers a facet, a perspective, a way in. None alone is enough. All together begin to reveal the richness beneath the surface. This interconnectedness is itself a reflection of reality's nature. Just as quantum entanglement links particles across space, so too are ideas, beings, and experiences intertwined. The boundaries between observer and observed, self and other, subject and object dissolve in the face of this unity. In embracing the mystery, we find a paradox. Certainty arises not from closure, but from openness. Strength emerges not from control, but from surrender. Meaning is born not from answers, but from questions. Our place in the universe is unique and yet connected. We are simultaneously solitary and part of a greater whole. Consciousness reflects on itself through us. What then is reality? It is the unfolding dance of existence. A play of light and shadow. A symphony of patterns and possibilities. It is what we see and what we cannot see. What we touch and what touches us. What we measure and what measures us. Reality is the eternal now, shimmering between what is and what could be. It is the great unknown beckoning us forward, inviting us to explore, to question, to wonder, and most importantly, to be. Because in the end, reality is not a place out there, it is the journey within. the story we live, the presence we are. And as we awaken to this truth, the universe awakens with us. To live is to participate in the great mystery. To wonder is to glimpse the infinite. And to ask, what is reality, is to begin to know ourselves.